Okay, now the combination is 16 times 3 because 16 times 3 is 48 and somehow 16 minus 3 is 13. This is the combination. Okay, maybe you spend a little bit time to determine the combination, but I am doing fast. So now you bring down 4x squared and you separate 13 using 16 and 3. Okay. Okay. Now this expression is equivalent to the original because you combine like there 16 minus 3 is 13, no? We're using the corresponding sign, positive 16 and negative 3. Now ready to apply factorization by grouping GCF in the first couple and GCF in the second couple. GCF in the first couple is 4x, open parenthesis, x plus 4. GCF in the second is negative 3, x plus 4. Let me check the sign, negative times positive, negative, negative times positive, negative. Okay, good. Now I can see the factor x plus 4 again is a common factor. Open the last parenthesis. Inside the last parenthesis we have 4x. So this 4x is this 4x and this minus 3. Okay, ready. And this was only the factorization of the trinomial in the left hand side. Any question, guys, so far? I suppose you remember very well factorization. Maybe you are doing different like me. This is a different way to do the factorization. Some people directly open two parentheses and try to guessing the number. I don't care. I don't care the way you are doing. You are doing factorization. This is basically the idea. Any question? Everyone follow me? Follow me? Follow me? Yes or no? Answer me. Good. Now, what should I do now? Well, after that, I convert temporary, Elizabeth, to equation because I want to find the critical value. Okay, I convert temporary to equation because the equation allows me to find the critical value. Each factor is equal to 0. And the first solution is negative 4. And the second solution is 4x equal 3 divided by 4. X is equal 3 over 4. And 3 over 4 in decimal is 0.75. Put in a calculator. Okay, this allows me create the partition in the order anomaly. Remember, in this moment of the solution, we stop algebra a little bit and I go directly to the graphic part. This is 0, 1, 2, 3, negative 4 partition and 0.75. I suppose that here is in between 0 and 1, close to 1 because it's 3/4, right? Approximately. Okay, this is the partition. This is negative 4 and this was 0.75. Now you select testing point. The testing point good is negative 5 maybe. Okay, 0 is super good and 1 is super good. Using that testing point, I create my table. Okay, negative 5, negative 5, 0, and 1. Okay, the factor involved in my problem are, or was, or yes, x plus 4 and 4x minus 3. And don't forget the last column gets the total column, total sign. Okay, negative 5 here is obvious as negative. Negative 5 here is obvious as negative. Because it's 4 times negative 5 is negative 20. Negative 20 minus 3 is negative 23. I don't care the value, I care the sign. 2 negative multiplication is positive. 0 is positive. 0 is negative. is negative. 1 is positive. 1 is positive. Is positive. Okay, I come back at the beginning. I can see that our original problem contains less than 0. And this is equivalent to say it's to be negative. Now the true guy on the table is the negative. This is the true. Therefore, the interval solution, the interval que incluye the testing point 0, que was the only testing point que passed the test. This is the answer. What about the endpoint? Well, the endpoint is not included inside the solution because our inequality do not contain equal sign. No equal sign. Therefore, we put a parenthesis here and a parenthesis here. And what is the answer? The final answer is then parenthesis -4, comma 3/4 in fraction or in decimal, either way. Okay, this is the answer. End the story. Any question? Because I want to see, guys, a different piece of information. This piece is algebra. This piece is algebra, but this is equation, critical value, no? This piece is the partition, is a graphic, and this piece is the table. Okay, so you omit one part. No, it's not correct. It's incorrect. Any question? Super. Yes or no?
Yes.
Okay, good. Easy. Okay, let's move on to the second question. Second question is graph. Graph one rational function que is f of x equal x over x plus 3. Remember the 7 step. Step 1 is factorization. In this case, it's impossible factorization because both polynomial x is a monomial, x plus 3 is a binomial, but we cannot do anything. So this step is missing. Now the second step is find the y-intercept. The y-intercept is the function of value 0. 0 over 0 plus 3 is obvious as 0. So the point is 0, 0, and when this situation happens, 0, 0 is both. It's x-intercept and y-intercept. Just in case, I want to check it. X-intercept, the formula is f of x equals 0. Remember, this is a fraction, and the fraction is equal to 0 when the top part is 0. Okay, again, we have the same situation, x equals 0, and this point is both x and y intercept. Okay, this is the step 2, step 3. Step 1, remember a factor, but it was missing because it's prime expression, factorization. Step 4 is vertical asymptote. And the determination of the vertical asymptote, you take q of x equal to 0. So always the expression in the denominator equal to 0 in order to find the vertical asymptote. X plus 3 equals 0. X is minus 3. Okay. So in this moment, I am doing my roughly sketch. This is the x-axis. I plot the point get 0. In -3, -1, -2, and -3, we have a vertical asymptote. It's the vertical asymptote. Number 5. Number 5 is horizontal asymptote or slant asymptote. Remember, to analyze that, we are doing the analysis of the degree. The degree of the polynomial in the top is 1. The degree of the polynomial in the bottom is also 1. And I know the rule that when the degree is the same, we have horizontal and no slant. Add the division of the leading coefficients, que es 1 here and 1 here. Entonces es obvio que at y equal 1, we have horizontals. Quickly, I want to verification if the curve, I try to do the graph, crosses or no the horizontals. The easy way is you take the original equation, x over x plus 3, and you enforce it to be equal 1 because of the value for the horizontal aspect. Okay. I solve this equation. I try to solve this equation, cross multiplication. Maybe x times 1 is x plus 3. I try x minus x equal 3, 0 equal 3. It's a perfect contradiction, it's totally false. That means que never our curve crosses the horizontal aspect. Okay, number 6 step is test of symmetry. Symmetry. Entonces, to testing symmetry, well, you, for example, replace x for negative x. So you make a reflection, no? Entonces, in the original equation, I want to copy the original. The original is x over x plus 3. Entonces es minus x over minus x plus 3. Suppose you divide or multiply by negative 1, top and bottom, this will have x positive, 3 minus x. And when you compare this and this, it's completely different. No opposite sign, no twin brother. It's completely different. That means that the function is neither. If it's neither, you need to plot the negative part completely independent for the positive part. Completely no symmetry, no symmetry. The symmetry failed. Okay, now I try to select totally additional point to complete the picture. Additional point. What are the criteria to selection the additional point? Well, and the partition that we are doing before, we have 0 here. It should be good, will be good, can you select 1, 2, 3, either way. O sea, the minimum value, at least 1, and this interval. So after 0. 1, let me use in blue color. I select this. I select, for example, negative 1 or negative 2. And this interval, so I'm in between 0 and negative 3. And I select negative 4, negative 5, completely arbitrary. And you evaluate the function. And 1, okay, this. Entonces 1 over 1 plus 3 is 1 quarter. 1 over 4. And the point I need to plot is the point 0, 1 quarter. Okay, let me copy just in case in my paper. Wait, another paper. Okay, additional point. I have a point is 1, 1 quarter, 0.25. Okay, one more, negative 2. F evaluate negative 2. Entonces negative 2 is negative 2 over negative 2 plus 3, no? Es negative 2 divided by positive 1 because 3 minus 2 is 1, entonces negative 2. And the famous point is negative 2, no? It's a coincidence. Okay. Negative 2 is negative 2. And 4, negative 4 is evaluating negative 4 is negative 4 divided by negative 4 plus 3, no? Okay, then negative 4 divided by negative 4 plus 3 is negative 1, which is positive 4. And the point is negative 4, positive 4. Okay, negative 4, positive 4. Okay, now I am doing the graph by hand. No, hello. You open Desmos. You open Desmos. Okay, I have a Desmos here. Okay, you open Desmos. Let me start at the beginning, step by step. Okay. Share the screen for Desmos. Do you see Desmos? Good. Now I copy our function. Is y equal, or f of x, whatever you want to call it, y equal x divided by x plus 3. Okay, there you go, something like that. I investigate also que the point 0,0 is the, you know, the y and x-intercept. I investigate also the vertical asymptote is the line x equal -3 equal -3. Oh no green, black color. Any convention is the asymptote is black color dotted line, something like that. This is the vertical asymptote. That makes sense because approach but never touch. The horizontal asymptote is y equal 1, no? Y equal 1. Y equal 1. Okay, again, black color dotted line. Black color dotted line. Okay, let me make it zoom. Oh, makes sense. Everything is clear. Now the additional point are, remember, comma separated by comma. You can put in another line with the same line, open parenthesis. It's 1 comma 1 comma 1/4 is 0.25. Either way, decimal or fraction. No, sorry. 25. 25. Boom, perfect. On the curve. Okay, now separated by comma, and the other interval was -2, no? -2, comma, -2. Boom, very well, on the curve. Also, the last one is -4, +4. -4, +4. Okay, comma, +4. Excellent. Okay, exactly here. And we have a good idea how it look like our graph. Any question, guys? This is the question 2, no? Question 2. Okay, let me condense this information in the question 2. Okay. I condensing. Yeah, I'm ready to create a new question. Any question? Are you strong in decimals? Do you understand very well? You need an extra explanation or no? Remember, in the test, when you finish that, you click here, okay, share the graph, okay, and you export, okay, and you download, okay, in your computer, like a picture, and you send it to me. Okay? Any question? No? Okay. Okay. The continuation is number 3 question is a quadratic function. Okay, it's a quadratic function. Okay, quadratic function now. Number 3. Graph the quadratic function, que I know que es a parabola, no? Graph. Number 3. We can see the whiteboard. Oh, sorry. Thank you. You always help me share whiteboard. There you go. Okay, graph. Entonces the function is calling the review package G is equal x squared minus 5x plus 8. Entonces I know, look at this equation, que A es 1, B es -5, and C is 8. You want to find the vertex, que is a super important point on the parabola. You find the formula H is equal minus P over 2A. The formula contains minus, be careful. B es negative. 2 times 1. Entonces, negative, double negative becomes positive, es 5 over 2. Okay, in decimal is 2.5. I convert to decimal when there's a fraction because it's easy to see in the graphic part. Now you evaluate G in order to find the K value, que is the Y component associated with the H. You evaluate G and 2.5. Okay, and you put it in my calculator. Let me try to put it in my calculator. Ready. Okay, the function is x squared minus 5x plus a. I try to evaluate this function at x equal to 0.5. Boom, the answer is 1.75. So in fraction is 7/4, in decimal is 1.75. Therefore, the vertex of the our parabola is located at the point 2.5, 1.75. And this parabola open up or open down. How do you know that? The control in what direction open the parabola is controlled by A. Si A is positive, in this case is 1, the parabola open up. And the vertex, que is that famous point, is this. We need more point. Of course, we need more point. We need, for example, y-intercept, que the formula es evaluated in 0. Es obvio que es A, ¿no? It's C always. The point 0,A belong to the our parabola. And x-intercept is g of x equals 0. So basically, I need to solve in this quadratic equation. Using the quadratic formula, maybe, no? The quadratic formula is minus b plus or minus square root b squared minus 4ac divided by 2a. B is -5, double minus of the formula. Sorry, I am late, professor. I have an internet issue. Okay, no problem. This. Okay, the important thing is you are here now. Entonces, 5, positive 5, plus or minus square root -5 square, que es b, minus 4 multiplication by 1, que es a, multiplication by c, que es 8. Okay, divided by 2 times 1. Okay, we focus, see, now in the expression inside the radical. Let me make a zoom. I focus in this. Okay, and -5 squared is 25. Minus, and this is 4 times 1 is 4, then 8 is 32. Entonces when the 25 minus 32 is -7. Entonces I know que square root negative number is imaginary or is complex. Si es complex, that means the interpretation, this is important to understand this, is because the x in a set, that I try to find do not exist. Okay, because they are complex. Okay, when you in algebra, when I try to find something and this something do not exist, well, it's complex, sorry, and it's because do not exist. This is the reason behind. Okay, now I have in my hand 1 point, get the vertex. I have 2 points. We have unfortunately no point, okay, but I know that never cross the x-axis. The axis of symmetry, the parabola, axis of symmetry of this parabola is a vertical line, x equal h, h is 2.5, for example. And this is split the parabola in 2 parts. This is the axis of symmetry is split, open up, no? Open up, sorry. Open up. The parabola open up. This is the axis of symmetry is split the parabola into different parts. I take advantage of the symmetry. And the parabola always is the axis of symmetry. Axis of symmetry, look. But let's go directly to decimals now to solve the problem. Let me copy in one piece of paper. The vertex is located at the point 2.5, 1.75, and the y-intercept was 0.8, It's the only point we have in my hand so far. Okay, no problem. I try to find more. Okay, let's go to Desmos. Okay, I share the screen to Desmos. Okay, Desmos. Good. Okay, that was question 2. This is history. Now I press enter. I create another folder, and this folder is called question 3, no? Question 3. And the question 3, the first thing you should do is copy the original equation. It's y equal. You can use in function notation or no, either way. Some people prefer g of x. No, y is okay. X squared minus 5x plus 8. Good. This is our parabola. Good. What is important? Super important point. One of the super important point is the vertex. The vertex is located at the point 2.5, 2.5, comma 1.75. Boom, perfect. Look at that. Nice. I like that. One more important point. Well, one more important point separated by a comma is 0.8, is the y in a set. 0.8. Okay, super good. I can see clear now, like a water, okay, this parabola never crossed the x-axis. That is the reason when I try to find the intercept, the answer was complex. It's because the parabola never crossed the x-axis. So using my common sense and my imagination, I can determine, well, okay, the axial symmetry is a line x equal 2.5, no? X equal 2.5. 2.5, boom. Look, it's the axial symmetry, black color, dotted line, black color. It's not asymptote, but it's the auxiliary construction. This is actually no parabola. This is one thing to understand the parabola. So I can understand that we have another point here. Okay, by the way, it's the point 5,8. How do you know the 5? Because the distance between 0 and the axial symmetry is 2.5. 2.5 plus 2.5 is 5. So we have another additional point without mathematics, using the common sense, is the point 5,8. So 5, the same y value of the y intercept, no? So we have 3 points. I know also the direction can open the parabola. Super. We finish. Any question? No. Okay, I like that. Okay, let's move on to the question 2. Okay. Whiteboard now. Okay. Let me erase the whiteboard. Go ahead. Question? Somebody say something?
Yes, we're on Desmos.
We are you see Desmos right now or whiteboard?
Desmos.
Okay. Let me confirmation. Okay, it's whiteboard. Whiteboard. Sometimes I can see, sometimes happen, depending the internet of the students, we have some delayed to see the information. But now you see whiteboard now? Yes or no?
No, I don't see anything.
No? Sabrina dice yes. Okay, entonces one possibility is you waiting a little bit, a few minutes, few seconds, no? Second, no minute. And or you go out, sign out, and come back again, get in again.
Okay, thank you.
This is one possibility. I hear that some people solve the problem. Okay, graph again. Number 4 is graph again, but it's a parabola again. Another parabola. Y equal minus parenthesis x plus 3 square. plus 5. Okay, this is a parabola, but this parabola is expressed in different way. It's expressed in vertex form, non-standard. Yeah, I need to remember in vertex form, the equation for the parabola is ax minus h squared plus k. And we compare this equation and this equation. I can see clear that a is -1. Look, this a is this -1. H, be careful with the H, is completely opposite sign, is -3. Why is -3? Because in the original equation I see positive. However, in the general equation in vertex form I see negative. The reason can become positive is because H is negative. And when you plug in negative, we have double negative, and double negative become positive. And K no. K is 5, directly the same answer. Okay, it's different answer here because it's negative. And this is the same answer because it's positive. Be careful with this part. Okay, so the vertex of the our parabola is located at the point h, k, que es -3, 5. And also a is negative. Therefore, this parabola open down. Let me try to find y in a set. Y in a set is evaluated at x0. Entonces y equal minus 0 plus 3 square 5. Okay, be careful with the sign. 0 plus 3 is 3, 3 square is 9, is -9. Plus 5 is -4. Okay, and the point is the point 0, -4. This is my y intercept. Okay, my x intercept is, you take the original function, que is minus x plus 3 square plus 5, and you enforce it to be equal to 0. And you solving this quadratic equation. In my opinion, the best way for solving this quadratic equation is using the square root, because I take advantage that somebody do the factorization that part. So as you move, for example, if I stay here, you move x plus 3 square. To remove this square, you find the square root both sides. And square root both sides is plus or minus square root. Here is x plus 3. And therefore is solve for x. X is equal -3 plus or minus radical 5. Entonces now we have irrational solutions. However, this is real, so we can plot. The first one is -3 plus radical 5. The second is -3 minus radical 5. Okay, let me try using my calculator to get the decimal approximation. Okay, -3 plus square root 5. It's negative 0.76. You round, 3 decimal places enough, like a decimus. Actually, it's no 4, it's 3.9. Okay, so you trunk it. Okay, this is approximately. And this is approximately, you see, -3 minus value of 5. Oh, it's minus again, both negative. 5.236. 236, yeah, 236. Okay, I need to copy this value. So far, I have in my hand the vertex is the point -3, positive 5. The y-intercept is the point 0, -4. And we discover now 2 x-intercept, is the point -0.764, and -5.236, okay, this is the situation for the hour parabola. And also get the parabola up and down, no? So we discover this point is the point -0.764, -5.236, Okay. What more important information we need? Well, we need the axial symmetry. Symmetry is always at the point or at the line x equal h. H in our example 3 and negative 3. Okay, this line split the parabola into equal parts. Maybe I take advantage to obtain additional point using the symmetry. Okay, no more blah blah blah. Let's go to Desmos. In Desmos, I try to plot everything. Okay, Desmos now here. Okay, there you go. Okay, this is question 4, no? Question 4. I create a folder to condense in all information for the question 4. Do we need? Question 4. Okay, first of all, let's copy the equation. The equation you copy exactly the same as given. No change anything. No algebra. Equal minus parentheses x plus 3. Well, not necessarily close the parenthesis because that's more automatic. I close the parenthesis, you put square. Plus 5. Okay, this is our parabola in black color. Okay, so it's okay in black color. Now, I discover that the vertex of this parabola is located at the point minus 3,5. Minus 3,5. Okay, super. And the label associated with this, minus 3,5. The parabola up and down. Yes, we determined that. What more important point? Well, is the point que es the y and z que es 0, -4, no 0, -4, 0, -4. Okay, super. There you go. Nice. And we discovered a little bit weird. X and z is the point negative 0.764, I guess so, no? 0. Okay, good, very good. And one more, the last one, que es parentheses negative 5.2, negative 5.236, 0. Bang, perfect. One more information we need. Well, we need the axial symmetry, que es the line x equal h, que in our problem h is -3. I don't like blue color, I like always black color. Dotted line. Entonces I want to change, bueno, the color of the curve. You click here and you change. What color you prefer? I prefer blue. I don't know why. Blue. Okay. Now one more. We need another additional point here. This point gets symmetric with this. It's nice. It's this point. Look. Not exactly. It's a -6, -4. Because this distance is 3. And the opposite direction is 3. 3 plus 3 is 6. Actually, it's not 6. It's -6 because it's to the left. So we have another point extra that we discover using the symmetry, que es the point, let me see again, es -6,4, ¿no? -6,4, -4. Done. Super, excellent parabola. We have 5 points, axial symmetry, open in the downward, everything clear. At least for me, I don't know you. Come on, question, guys. What part is confusing? We're doing number 4 question. No? Okay. Nice. Let's go to the whiteboard. Whiteboard now. Okay. erase whiteboard. Okay. Let's move on to the question 5. Question 5 is similar to the question 2, but a little bit more complicated. Okay, is the function f of x graph is equal x squared plus 4x plus 3 divided by 9 minus x squared. Remember the step 1. Okay, in the question 2, we skip that because it was impossible. But in this case, no. In this case, possible. Factorization, the trinomial, and the top, que es 3 and 1, no? 3 and 1. 3 and 1. Positive of. And factorization, this is typical differences of the square. Two parentheses. Square root the first is 3. Square root the second is x. Plus or minus. Plus or minus. Entonces we discover que this guy is the same. This guy is the same. And you cancel out. Doesn't matter that the order is switching because it's addition. Entonces addition is totally commutative. So you cancel out. Entonces now our expression is equivalent to x plus 1 over 3 minus x. Okay, don't worry about this. But don't forget that we discover in the step 1 that we have a hole. We have a hole at x equal minus 3. Get the 0 here. Minus 3 plus 3 is 0. No, see, this is at. Entonces, this is expression is equivalent to this, que es Caesar. Pero consideration, under the consideration, the whole, que es x no negative 3. So this complete statement is equivalent to this. Pero my question is, do the graph of this. See, I want to do the graph of this, I want to take advantage to do the graph of this, que es easier. Under the consideration that in 3 we have a whole. Clear? Okay, so we pay attention, we focus 100% my attention in the expression, new expression, f of x equal x plus 1 divided by 3 minus x. And the step number 2 is find the y-intercept. Y-intercept is the function of value is 0. So it's 0 plus 1, 3 minus 0. It's 1/3. Okay, so we have a y-intercept at the point 0, 1/3. Likewise, x-intercept, evaluate the function, so you force it to be 0. And to be 0, when it's a fraction, the responsibility to be 0 is only the top part. I don't care the bottom part. Therefore, I take the polynomial in the top, que es x plus 1, ignore totally the polynomial in the denominator, I solve for x. The solution is -1. So I discover that at the point -1, 0, we have x-intercept. In other words, is the graph is the point when this function crosses the x-axis. Okay, this is step 2. This is the step 3. Step 4 always is vertical asymptote. Vertical asymptote, remember, you take the denominator equal to 0. Now it's different, it's 3 minus x equal to 0. Therefore, x equal 3. Oh, just at x equal 3, we have vertical asymptote. This is a moment I like to start a little bit the roughly sketch. Okay, I completed in this mode, of course. It's all real number line. This is represent the x-axis. I plot this que es -1. This is 0. It's a -1. In -1 we have a point, que es this point. Y en +3, -1. +3, 1, 2, 3, we have vertical asymptote. This helped me to make a selection of the additional point that we need. or at least the minimum. Okay, number 5 is determine a horizontal or slant. Remember, it's analysis of the degree. Degree of what? Of the original or the new one. Doesn't matter. It doesn't matter. Remember, the only difference between these is we have a hole and fill. Therefore, all analysis you can do using this. Only consideration okay, we have a hole here. Okay, see, I pay my attention, and the new one gets easy. The degree of this is 1. And the degree of this is also 1. Therefore, when the degree is the same, I know very well that we have horizontal, no slant. At y equal -1, I guess so, no? Where come from this -1? It's the division, this coefficient, and this coefficient, and -1. As I want to investigate if the graph cross or not the horizontal asymptote, entonces es x plus 1 over 3 minus x should be, I enforce it to be equal -1. I try to solve this equation. X plus 1, multiplication this and this, gets 1, and multiplication is -1, conjugate multiplication -1 times 3 minus x, is x plus 1, this is -3 plus x. Wow, look at that, what happened. This x is cancelled, it's obvious, right? In the same side and the same side, and we have a contradiction. 1 equals -3, it's completely false, and the interpretation is never, our curve crosses the horizontal asymptote. Okay, symmetry. It's obvious that we have no symmetry. No symmetry. How do you know that? Because it's obvious that when you are making reflection in the original -x plus 1 over 3 plus x, this is completely different to the original. No odd function. It's neither. That means that the negative part and the positive part we are doing completely different. Okay, this is a moment to select the additional point. I come back to this sketch. In this sketch, I can see that -1 we have important point. Therefore, 0. Well, 0 actually I have the value is 1/3. So I take advantage of this. For example, I pick 2. Remember, in 3 we have a hole. In 3 we have a hole. And -3, sorry, we have a hole. I pick 2. I pick, for example, -2 or -4 to evaluate the function. Okay, let me show you. Let's do it quickly in Desmos now. No, I need to open. Okay, good. Okay, good. Desmos now. Okay, I propose one new idea. The new idea is, this is question 5, no? Before the question 5. Question 5. I want to call the function f of x. No, why? Because I want to illustrate the advantage to say that f parenthesis, sorry, open parenthesis x. Entonces I copy, I don't know si I want to copy the original or the new one. Well, let's copy the original, why not? Entonces, open parenthesis, x squared plus 4x plus 3. Close the parenthesis, division. And the denominator is 9 minus x squared. Boom. The point we discovered was, wow, I don't remember, I don't copy. The number, for example, the y-intercept was 0.1/3, no? Okay, let me plot that point. 0,1/3. Bang. Bang. Excellent. 1/3. The x in the cell was separated by a comma, -1,0. Bang. Perfect. Okay. No more point, no more point. For the moment, the vertical asymptote was in +3. So the line x equal 3. Boom. No red color, black color. Dotted line. And the horizontal, I don't remember very well, was -1. -1, yes. -1, y equal -1. And also we discovered that the curve never crossed this asymptote because we have no solution. Okay, the only thing we need to do is plot additional point. For example, good, you select arbitrary. So you select 4. You select 4. You select 4. Or 6 or whatever you want. Okay, you select 4. 4 is good. 4 is good. So you put a comma, a paréntesis, and you put 4, positive 4, comma. Entonces you don't need to evaluate directly in the calculator. No. You put F, you using the function notation. Parenthesis 4. Bam! You plot the point. Look at that. Fantastic, right? Okay. And likewise, we are doing another maybe. But don't forget, the important thing is totally independent in other line. Don't forget the hole. Don't forget the hole. Okay, the hole is located in -3, no? In -3. Let me see. Absolutely. In yeah, in -3. The hole is located in -3. Okay. So in -3 we have a point. Okay, I have no idea. You evaluate. Okay, you evaluate, pero you evaluate where? Okay, you evaluate in the function I want to call g. And who is g? So g is the region after the simplification. Look. G is. Let me see on the whiteboard. G is x plus 1 divided by 3 minus x. Okay, guys. I know we almost finished. Okay, but let me finish at least number 5 question. I go to Desmos. Is x plus 1, open parenthesis, x plus 1, plus 1. Okay. Close the parenthesis. Divided by 3 minus x. Okay, 3 minus x. And you see, wow, look at that. Interesting. The curve que es equivalent is exactly the same. It's exactly the same for the purple color. Green and purple colors except in 3. Therefore, I create another line in which I put the point, the famous point, the super important point, que is the point, the hole is located in -3, no? In -3. Let me see. The whiteboard. Oh yes, the hole is located in -3. So I put in -3. Okay. Do you see Desmos? The point is parenthesis, -3, comma, no F. Why no F? Because you put F as undefined. But G no, it's undefined because you remove the hole. So you put G, parenthesis, -3. -3. Boom. Okay. Pero no. No. I don't like this. I want to change the color of the hole. Let me use in black. And the style case, like open. This is the hole. It's located at the point actually, and the original function is undefined, to be undefined. Any question? Any question? Any question? We're doing today 5 questions. Wow. Go ahead. Go ahead.
Can I just minus 3 and just make whole?
I don't understand very well. You echo. Speak slowly and clear.
Okay. Can it be possible to write 3 and not write all for the whole?
I don't know what happened with the audio. Okay, I don't understand you very well. Could you typing? What is your problem? Your problem is in the whole part? Yes. Okay, Helena. In the whole part, okay, the graph of the function when you remove the whole is this green color. So what is the difference between the original function and the green after they remove the whole? Well, it's the same graph except the whole. Therefore, to find the position of the whole, I using not the original f, because in the original f, let me show you. In the original f, suppose I want to find the value of the original f. Look at -3. Look at what is the answer, undefined. The reason is clear, because it's a whole. However, I can evaluate in G. G evaluate in -3. It's not undefined. Oh, sorry, carajo. G evaluate in -3 is non-defined, is, you know, -0.33, one third. Okay, therefore, I using G to, you know, find the position, location of the hole. Make sense or no? More clear now? Yes! Okay, guys. Let's continue Monday. Remember, my plan is Monday I try to finish. I don't know if I can or no. If I cannot finish, well, we continue. When we finish everything, this is the moment to apply the test. Okay? Okay? See you.
Thank you.
Bye. My pleasure. Always, anytime.